Hello everyone, welcome to another episode from Chedexcel. Today we are going to talk here about forces of attractions, if not intermolecular attractive forces. This is the second chapter of Unit 2 of IAL Edexcel syllabus. We will see what are the forces of attraction and how they are formed, and what are the main types of forces of attractions, and what are the factors depend on the forces of attraction. I am going to divide this video in series into three parts. So, the first part I am going to talk about how to identify a molecule, whether it is a polar or non-polar, and then how to determine which type of forces of attraction present, and I am going to talk about the first forces of attraction type, which is London forces. Then the second part I am going to discuss the permanent dipole attractive forces and the intermolecular hydrogen bonding. In the third part we are going to talk about the factors affecting the forces of attraction, or factors depend on forces of attraction, mainly the water solubility and the boiling point variations. And there we are going to talk you about another forces of attraction type, which is called as dipole ion dipole attractive forces, right. So, first we will see what are the types of attractive forces present and from which substances we can see them. Now, the name itself gives you an idea, intermolecular attractive forces, which means the forces of attractions are present among the molecules. The molecules are formed from the covalent bonding, not from the ionic or metallic. So, we are going to talk here about the forces of attraction present in simple covalent molecules. So, if a substance you are going to talk or you are getting in the exam paper is not a simple molecule, then you do not have forces of attraction, like diamond, graphite. Inside graphite we have some sort of, but generally forces of attractions are coming with the simple molecular structures. Now, when you talk about the simple molecular structures, first you have to know whether that molecule is polar or non-polar. We are going to talk about this in depth in unit 1 under the bonding and structure. Right now I am going to talk you about the basic things you should know. How to identify, or how do you figure it out that whether a given molecule is polar or non-polar? So, very easy. The first thing is this. Let us talk about a polar molecule. Which molecules are polar? For a molecule to be polar, it can be two reasons. One reason is having a lone pair on the central atom. That makes the molecule usually a polar, having a lone pair on central atom. For example, ammonia, NH3, you have a lone pair on nitrogen. H2O, you have two lone pairs on hydrogen, right. SO2, you have again a lone pair on sulfur. So, how do you know the structures of these molecules? That thing come under unit 1. I will put a separate video on that. So, this is that thing come under unit 1, bonding and structure. So, if you have a lone pair, then on the central atom usually that molecule is polar. The second thing is not having the similar elements around the central atom, right. So, not having the similar elements around the central atom. Second reason is not having the same element around the central atom. For example, CHCl3, there is no any lone pair on carbon, but it has different elements, chlorine and hydrogen. So, this molecule is polar. Another one we can say, okay, POCl3, phosphorus, chlorine, tetrahedral structure, but different elements around the central atom, which is phosphorus. So, if you have similar different elements around the central atom, or if there is a lone pair on the central atom, usually that molecule is polar, right. Then how do you figure it out? The non-polar molecules, right. For a molecule to be non-polar, it should have the both above properties, which means you should not have a lone pair and you should have the similar elements around the central atom, right. SO3, similar elements around the central atom and no lone pair on the central atom. You have lone pairs on oxygen, that does not matter, right, SO3. Then CCl4, similar element around the central atom, but no lone pairs on the central atom. What else? Like that we can have many SF6, that is also nonpolar. Other than that, you can have organic compounds. Normally we say alkanes are nonpolar, right? Alkenes can also be nonpolar, like C2H2, C2H4. If the effect of hydrogen atoms get cancelled off, here C2H4 is nonpolar. Similar thing, let's say C2H4, that is also nonpolar because the effects of two fluorine atoms get cancelled off. So normally alkanes are 100% nonpolar. Alkenes can also be nonpolar if it is symmetric around the central atom. So those are the nonpolar molecules, the one which doesn't have a lone pair on the central atom and the one which have the similar elements around the central atom. So depending on whether the molecule is polar or nonpolar, the type of attractive forces they have is different, right. So we are going to look at what are those common three types of forces of attraction that comes under, right. So you have to remember how to find out or how to figure it out whether the molecule is polar or nonpolar. After you figure it out whether a given substance is a polar or nonpolar, then we have to know what type of attractive force it has. So if I write like this, forces of attraction, then here this side I will write polar, and this side if I write nonpolar. Okay, polar molecules again we can divide into two. Molecules with NH, OH and FH bonds, other polar molecules, nonpolar molecules, just nonpolar, right. So what are the types of attractive forces we can have? Nonpolar, we say they have London forces. Molecules with NH, OH and FH bonds, we say it has intermolecular hydrogen bonding. This one we say they have permanent dipole attractive forces. So these are the three common types of forces of attraction we have: London forces, intermolecular hydrogen bonding and permanent dipole attractive forces. So we will see in this part, the first part, how to find out what are the London forces and what are the, how do you understand or identify whether a molecule has London forces or not, right. So now we will see how to figure it out, London forces, right. We will see London forces. London forces. Now first thing to understand, remember is I am telling the basic theory parts. The term dispersion forces or instantaneous dipole forces is also used instead of London forces, but London forces is a very common term we always use. London forces are present in any molecule, whether it is polar or nonpolar. I did not write it in the earlier one, but remember, nonpolar or polar does not matter, London forces are present in any molecule because London forces depends on the number of electrons. Every molecule have electrons, therefore London forces are there in any molecules, no need to be nonpolar, but London forces is the only type of attractive force you can find in nonpolar molecules. Then the London forces arise due to the instantaneous dipoles made in the adjacent atoms due to their movements. So if they ask how does the London forces arise, because the molecules are not actually stay still, right. Any nonpolar molecule also they start to move. So when they move, they have vibrations, they have stretching, they have bendings. So due to those stretching and bending, sometimes a slight positive and negative charge can create. For example, when you write the mechanism of alkenes with bromine, we write bromine molecules like this, delta positive, delta negative, Bromine is a nonpolar molecule. So, how can it has this delta positive charge? Not because of this bromine, but actually what happens here is when the molecules move and when it come closer to the more electron dense place, which is a double bond which has 4 electrons, there would be a possibility to have or to induce a slight polarity. So, that is how these nonpolar molecules can create some dipoles. So, therefore, if we forget about this one, another bromine molecule can attract this one with delta positive and delta negative terminals. So, that is what we call as instantaneous dipoles, and that forces of attraction is what we call as London forces. The London force's strength depends on number of electrons. Higher the number of electrons, stronger the London forces. That is the reason why chlorine is a gas, bromine is a liquid and iodine is a solid, because bromine has more electrons than chlorine, iodine has more electrons than bromine. So, the London force's strength in bromine is higher than chlorine, iodine is higher than bromine. So, that makes iodine molecule to be in the solid state, whereas bromine is a liquid and chlorine is a gas, right. So, that is another thing to remember. The last one is, other than nonpolar molecules, you can see the London forces in monoatomic elements such as helium, neon, argon. Those elements can also exist London forces, right. And other than that, sulfur molecules, right, S8 sulfur usually exists, phosphorus usually exists as P4. So, S8, P4, those molecules can also have London forces because they are nonpolar. So, if I summarize again London forces part into 5-6 points, the first thing is London forces are present in every molecule, and as they are depend on number of electrons. All the molecules have electrons, so London forces are there in every molecule. The second thing is the London forces arise due to the instantaneous dipoles created on the adjacent atom due to their movements, right. That is how we create the London forces. Third one is the London forces strength depend on the number of electrons have. Higher the number of electrons, stronger the London forces. Usually higher the number of electrons means higher the molar mass, also we can say stronger the London forces. Then the London forces are present not only in nonpolar molecules but also polar molecules, I told it earlier, but other than that we can say we can find them in monoatomic elements like helium, neon, argon, or sometimes in carbon chains, alkanes, alkenes, we normally have London forces. Usually the carbon chain usually contains London forces, right. So, that is the basic idea of London forces, and we use the term instantaneous dipole forces. We rarely use that one, but we can use the word dispersion forces as well. Sometimes we use the word van der Waals forces, but van der Waals forces is not specifically used for London forces. Instead of London forces, we can use the word dispersion forces, but more commonly we use the term London forces. So, that is what the first type of the forces of attraction present. So, in the next video I will be talking about permanent dipole attractive forces and intermolecular hydrogen bonding. So, this is the first part. We just talk about how to identify whether the molecule is polar or non-polar. Then depending on that, we discuss the very first type of attractive force, which is a London force, and we will talk about what are them and how they arise, and what is the factor that depends on the strength, which I told the number of electrons, right. So, that is it, that is the first part. So, if this is helpful, give us a thumbs up and consider subscribing. Thanks for watching.